All right, let's look at this problem from 2017. It's a differential equations problem. Let's see, they give you an initial condition here. Here is the differential equation. It represents the internal temperature of a potato. And question A is to write the equation of a line tangent at 0. So in that case, you'll always need a point and a slope. And when it is a differential equation problem, this is usually extremely easy. The point they gave you was 0.91. The slope is going to be the derivative at that point, and my derivative here is given to us. So the slope would be dh dt at the point 0.91, and what you have to be careful with is that dh dt, the given derivative, is a function of the dependent variable. So we actually will plug in 91 to the differential equation. So this is going to be negative 1/4 of 91 minus 27. 91 minus 27 is 64. And 64 divided by 4 is 16. So we get a slope of negative 16. And so my tangent equation would be y minus 91 equals negative 16 x minus 0. And then it says use that to approximate the temperature at time t equals 3. So my temperature at time 3 is going to be approximately negative 16 times 3 minus 0 plus 91, and you can stop there. However, if you want to simplify that, I should have grabbed my calculator before. Oh, this is a non-calculator question. No, I should not have grabbed my calculator. 91 minus 48, see 91 minus 50 is 41, so it'd be 43 degrees. Yeah. Always include units. This is degrees Celsius, not Fahrenheit. And there's your answer to part A. Part B asks you to use the second derivative to determine if this is an under or an overestimate. So first, let's get the second derivative. And again, you have to be careful because the first derivative is a function of h, not a t. And because we are differentiating with respect to t, that means I have to give the h the implicit treatment. Let's see, so the negative 1/4 in front, I would just leave that alone. I wouldn't include that at all in the derivative. I'm not going to think about it. I'm going to just let it come along for the ride. The derivative of h would be 1. However, we have to multiply by dh dt. And 27 would obviously zero out. They do not tell you to write the second derivative in terms of h. However, if they did, you would need to go one step further and replace dh dt with the equation that is given for dh dt. So I'll plug in negative 1/4 times h minus 27, but that is not necessary in this particular problem because they did not tell you to write the second derivative in terms of h and t. Just know that that is how you would do that if needed. Now the next part, they do say use this second derivative to determine if this approximation in part A is an over or an underestimate. Well, the second derivative is used to find concavity. That's one of the uses for the second derivative. And in part A, what I did is I found a tangent to the curve, and I need to know if this tangent is above or below the actual curve. So I'm going to plug the point 0.91 into my second derivative. So my second derivative, d squared h over dt squared, at the point 0.91 would be negative 1/4. And here's where I'm going to take advantage of some previous work. It's negative 1/4 dh dt. And in part A, we found that dh dt was negative 16. Hang on, I'm thinking for a second. I need to look up here for just a second. I just had a thought. Okay. They tell you up here, I'm going to go a different route. I'm sorry, I just had a second thought. I'm going to get rid of this completely. Okay, my thought process was I'm going to plug in part A, we found that DHDT was negative 16, so I was going to plug negative 16 in here to get a value of 4. That is a positive value, which means that at that point, the curve is concave up. And if your curve is concave up, then a tangent would lie below the curve, giving you underestimates. So that would mean part A is an underestimate. However, the slight flaw in using the specific point to determine concavity is that that just tells us that we're concave up at that point. Maybe when we get to 3, which is the point we estimated, maybe by the time we get all the way over to 3, the function turns back to concave down. And that's something we have to worry about, is the concavity between the point of tangency and the point we estimated. So what I'm going to do is, if you look back up at the information, they tell you that the potato is left to cool. If the potato is cool, that means your temperature is decreasing, which means that H prime would be less than 0. So because the temperature of the potato is cooling, we know that the derivative is always negative. And so since the potato is cooling, that means that dH dt is negative, and therefore my second derivative is going to be negative 1/4 times some negative value, and my second derivative is positive for all values of t. And then I could conclude that the function h is concave up always, not just specifically at the point 091, but is concave up for all values of t.